You saw how using an anonymous inner class greatly simplifies the notation that we require to implement an event handler. It turns out that we can go even further yet with something called Lambda expressions. This is a new feature that only exists in Java 8 and onwards. A Lambda expression is basically just the anonymous class with a new concise syntax for it that you see illustrated in the slide pictures below in this slide. In diagram A on the left, we have the syntax by way of review that we already talked about in our previous demonstration of an anonymous inner class. Now the compiler is smart enough to know that when you use the setAction method, you're expecting to have as an argument an action event object, and in this case we call it lowercase e, but we could name it whatever we want. So if you look on diagram A, you can see where that has been defined as an argument action event e. Now when we use the lambda expression notation, what we do is we simply provide e and then this little arrow symbol that you see in diagram B on the left. So there's a lowercase e and then a dash and a greater than, which represents a sort of an arrow. The compiler sees this in the context of a parameter for set on action for that method, and it knows that method is going to have to require an action event, so it automatically knows what E is. E is an object of class action event. Furthermore, by context, it knows that what you want to put here is an event handler that handles an action event and that you're going to override the handle method. So it gobbles all that up for you and just understands that that's what you want to do, allowing you to simply show that special notation and then a pair of curly parentheses in which you show the complete implementation for your handling function. Comparing the syntax on the left with the syntax on the right, there's clearly a nice advantage here. It's really going to streamline your code and make it look much nicer this way. It may be somewhat confusing to understand why this is supposed to represent what's on A. So in other words, what you see in B, that E arrow is supposed to represent what you see in A. But don't overthink it and don't worry about it too much. It's just a notation and it's just been designed to simplify things, and that's all it is. So I guess the word of advice here is simply accept that notation for what it is as a shortcut. Generalizing this lambda expression notation, we see the basic syntax for it is one of the two things that you see on the slide here. Either you're going to have a comma delimited list of parameters and each will have a type associated with it, and that's enclosed in round parentheses. So in other words, type 1 parameter 1 comma, type 2 parameter 2 comma, and so on. And then you have that little arrow notation consisting of the dash and the greater than sign, and then an expression that is a particular statement that you want to perform. Alternatively, if you want to do a number of things, then you will have to add to that same syntax a pair of curly braces to denote a block, and then a block of statements. So several statements perhaps then would go in that block. Now in this context, the compiler will infer what the type of the parameters are. So although you're allowed to explicitly declare it, which has been what's been done here, so we've specifically said parameter 1 is of type 1, parameter 2 is of type 2. You don't need to do that in this notation because the compiler will be able to figure out what the type of each parameter is, making it unnecessary for you to actually list the types. Furthermore, the round parentheses that you see there are only required in the event that there's more than one parameter involved. In the example we looked at just momentarily, just a while ago, we saw that there was only one parameter e, and because of that we were able to dispense with the round parentheses, and also we didn't have a type, so we just had an e all by itself in that case. In a lambda expression, the statements that you list are all for that particular method. If you need multiple methods, the compiler is not going to be able to compile it with a lambda expression. So if you wish to use lambda expressions, it has to be used in the context where the interface you're dealing with has to contain exactly one abstract method. If there's multiple methods, you won't be able to do this. And this gives rise to the name that we use here, single abstract method interface. There is only one single abstract method being overridden. We also call this then a functional interface. To wrap up our discussion of lambda expressions then, we have a slide here that shows a sort of evolution of using more complicated to simpler and simpler notation. Let's start at the top and notice the sections in red, which are different as we go down from example to example. So in the case of the up button, we do dot set on action, and then in round parentheses we have action event E, and then the lambda symbol, the dash followed by the greater than sign, and then the implementation for this particular method. Here what we've done is explicitly declared the data type for the parameter. But again, with lambda expressions, we don't need to do that, so we can simply omit it. And in the next step, that's what you see happening. So here, the compiler is going to infer what the parameter type is for E. And now we're talking about the second example down on the slide where we have just an E in parentheses all by itself. But now, because we only have a single parameter, the lambda expression notation allows us to dispense with the parentheses. We don't need them at all. So now we omit them, and this is the third example down for the left button this time. So we have button left dot set on action, and in parentheses now we have just an E all by itself with no parentheses around it, and then the arrow notation next, and then the definition of the method that's being overridden. And now we have one final step in the evolution here, and that is that we've thrown away the curly braces. The reason we're allowed to do that here is because there is only a single statement, although it's a complicated looking statement since it's a conditional, it's still a single Java statement, and therefore there's no need to put the parentheses around it. Parentheses are usually used to indicate a block of statements, and we only have a single statement, so we simply throw those parentheses out. That's consistent with other structures such as for loops and while loops and if statements. If you only have one thing to do, you don't need to produce a block using curly braces, and the same is true here. With the lambda expression notation, if you only have a single statement, there's no need to put it in a block, and therefore no need to include the opening and curly brace.